Our last session speaker today is Kathy Zhong from Google. Kathy is a principal data scientist working on Google Ads. She manages a data science team and mainly focuses on search ads and shopping ads. She drives efforts to validate and improve logging data, design experiments for rigorous measurement, develop evaluation metrics to assess quality versus revenue trade-off, and explore new opportunities to shape product growth. Kathy today will give us a glimpse of Google search ads experiments. Kathy?
Yeah, thanks for having me here. Let me share my deck. Can you see?
Yeah, can you slideshow? On the top right. The slideshow beside sharing.
Does that work now?
Yeah. So now it's,
okay,
it's
great.
It's
yeah, finally. Okay, thanks for having me here. My name is Kathy. I'm very happy to join the session today and to talk about Google's experimental infrastructure. So before I start to talk, let me spend 1 minute to introduce my team. I work in the team called the Ads Metrics team in the Sage PA, and Sage here just represents the Google search ads business and the other related ads on the Google experiences, such as the Discover ads, Map ads, etc. This is a data science team, and we work very closely with the engineering team, product teams, and other job ladders like UXR, UX teams. And we're in general, just trying to be responsible for driving the Google's revenue and business growth. And in part of my slides, we'll talk about how do we use the experiment to guide the long-term business growth. Okay, so before I start to talk about the technical part in this deck, I think it might be interesting to explain a little bit what a data scientist do in Google. So whenever we take on a project, I would say the first phase might be to frame the analytical questions. So usually the question coming to me is a business question. For example, how do we help advertisers come on board much more easily? So this is a business need, but nobody really can be very clear about what are the metrics to define, to monitor, to track this performance. So first of all, what we need to do is to take the business question and trying to build up the business context, understand what this means, and define the metrics. Then we start the exploration stage. We're going to look into the data. A lot of the effort actually will be spent on validating the data. So as many of you know, Google has tons of data, but also, as expected, not all of the data are perfect. So we're going to do a lot of the data sanity check, a lot of the data exploration analysis. And through this process, we hope to identify, better intuition, what is going on, whether this problem is really bad, what are a few ideas we think can potentially trying to bring up to the experiment stage, trying to see whether that helps. And that naturally transitions the whole process to the experimental stage, and where we're going to carefully design the experiment. Sometimes A/B testing doesn't work, then we also have to reuse, leverage some causal inference modeling, trying to get a measurement. Sometimes we not only care about the short-term metrics, but also care about the long-term metrics. And in today's talk, I'll give a little overview regarding like how do we design experiments and measure the long-term effect, right? And after the experimentation stage, ideally we should form some hypothesis. We should do the testing. We should let the data to guide our decision to validate what we think is as expected or not, and whether we want to really launch this. And that brings us to the productionized stage. And I would also say, through the whole process, communication is a very key thing, because almost like a day-to-day, we need to communicate a lot with all the stakeholders. And that brings to this slide. What do I think could be the most important skills to be a good data scientist working in Google? I want to say this is a very subjective question, and different people might have different answers. When I think about my 10 years of experience in Google, this is the slide I made, obviously. The first thing I want to say is probably being very logical and ask very good questions. In order to ask very good questions, one of the fundamental thing we need to be good is actually to build up our business context. If I work in ads, there's certainly a lot of the domain knowledge I learned or I need to learn. But one day if I switch my job to work in YouTube, I actually think a lot of the stats background, modeling, those things can be immediately applied. However, the business context, the domain knowledge is something I need to catch up as well. And the second category isn't going to be surprising, right? That is like the coding, the stats background, stats background, experiment design, causal inference modeling, all of those things set us like with a very good solid foundation to do the very thorough analysis and allows us to derive sharp data intuition. And the third one I'll say is very good communication skills. As a data scientist, sometimes I try to ask myself, what is the biggest value I can bring to Google? I actually feel the biggest value is probably the intuition I can help them derive from the data, right? So I got my intuition. It is my job to communicate my intuition precisely, to communicate to all my stakeholders what are the caveats I see in the data, in what way I see an experiment is doing good, in what way I see the experiment has the issues, right? And help the organization to make a better decision. So in order to reach this goal, I will say communication is very important as well. Sorry. With that, I think I can get to talk about the technical part for today's presentation. In this deck, I have like three things I want to cover. First, I want to talk about the overlapping experimental infrastructure. Then I'll talk about how do we measure the counterfactual effects. I'm not so sure whether this name is very well known outside of Google, but I will explain later. And after that, I'll talk about why do we need to measure the long-term effects, and give a taste about how do we measure the long-term effects, especially the user learning effects. So what we're looking at here is a typical A/B testing. So we have some traffic. Let's say we just allocate 50% of the traffic to experiment A, right? And then 50% of the traffic to experiment B. Because the traffic is randomly allocated, so we somewhat can assume the user who is going to experience experiment A, the user cohort is actually the same compared to those who is going to experience or going to be treated in experiment B. This is a typical A/B test setting, which means by observing how users interact with two settings, we'll be able to interpret the difference as the treatment effect. Many years ago, back to 2007, what I'm showing here is the typical way how Google runs experiments. At that time, or even earlier time, we only had one layer, right? So, like we say, we have like 100 users. Let me just treat one user in control and then put another user in treatment. And let's say, this is A/B testing. And it's also like randomized. But the problem of this infrastructure is it is very simple. It's very straightforward. However, it's not very scalable. So if I have like a Google's 100% of the traffic, and let's say every experiment, in order to reach some power, I really need to use 1% of the traffic. This means with one layer, I can at most run 100 experiments at the same time, and that's insufficient for Google. Constantly, Google running thousands, if not tens of thousands of experiments and testing the features. And we're trying to use the data to help us guide us for the better product development. So we came up with the idea of a layer. Experimental layer is also easy to understand. That just means within a layer, I'm just going to group features somewhat similar together. For example, you can imagine I introduce a layer called UI layer. For UI, ads UI is basically responsible for changing the ad font size. You know, how much space to show, you know, the title, how does that look? What is the font and what is the font size, what is the color. You know, when you go to google.com and search for something like shoes, you're going to see the ads there. How does the ads look basically goes to this UI layer. And we can also introduce another layer called ranking layer. In the ranking layer, you know, we can use that to test some quality signal improvements. For example, I should have a model to predict what is the chance a user is going to click on the ad. I should have another model to predict how much to bid if the advertiser opts into the auto bidding, how much to bid on this query, this keyword, bid for this ad for this user, right? So in the ranking layer, we can run this type of like experiments and some option changes and figure out the ranking of the ad, which means, you know, which ad is ranked at the first position, which ad is shown in the second position. The benefit of grouping the similar features into a layer is because within the layer, the traffic is actually exclusive. So this can also avoid the accidental mistake. Say, you know, I have an experiment, accidentally changing the front end font color to be black, but also accidentally change the back end color to be black. Okay. So now I want to introduce the layer. Let me just use this. So this one, this plot here gives a more conceptual illustration. What if I have like two layers? On the x-axis here, you can see this is the layer X, and the y-axis here shows this is another layer, right? So within each layer, let's say, I don't know whether every of you can see my mouse, but imagine we're reading the two rows horizontally. The control group number 1, experimental group number 1 here highlighted, right? They are actually, as I said, mutually exclusive. And similarly, if we look at the control group number 2, experimental group number 2, they're also mutually exclusive. So certainly between the layers, there can be some intersection, right? This means the user, for example, is under both the experimental group 2 as well as the experimental group 1. However, by introducing multiple layers as orthogonal to each other, the benefit is like one, the whole experiment infra can become scalable. Second, within a layer, right? Although some of the users, they are under multiple experiments, but if we can assume the interaction effect is largely cancelled out, this is the infra can still allow us to do A/B testing comparison for experiments within a layer. With that, I'll try to talk about the second topic. How do we measure the counterfactual effect? On the left plot here, what I'm showing is the plot I just explained, the typical A/B testing, right? So traffic goes to A, traffic goes to B. You know, some of the users are being treated by experiment A, the other are being treated by experiment B. Then we observe how users respond to those experiment settings and interpret the differences as the treatment differ. For the counterfactual, the setting is slightly different. Let's say the user issues a query. We again decide to allocate this user to experiment A just randomly, right? So the user in real time sees the experiment A's treatment and interacts with experiment A. However, in the backend, what we're going to divert is the same query the user issues, pass this query through the whole serving flow under the experiment B setting. In this flow, we're going to log measurably what Google is going to show to the user should this user being allocated to experiment B. So in a way, if I want to give a metaphor, I will basically say the A/B testing somewhat mimics, the testing, the typical T testing. But counterfactual really allows us to find out on each query, what happens. So it is less noise. It allows us to analyze, on each of the specific queries, some questions such as whether we're showing exactly the same ads or how the ads are different. Right. So for example, once I pass the user A setting to the real serving time, I can log what the user sees. And once I take this query runs through the whole serving flow, I will log what the Google is going to serve to the user. So assuming we have that, we'll be able to understand some details regarding how the ads are served to the users. And we have the predicted signals. Here is very important. Predicted signals to tell us whether we're serving the user better predicted ads or worse predicted ads. It will also help us understand, on how many of the queries we are showing exactly the same ads. How many of the queries we're showing the same number of ads, but a slightly different set of the ads, or sometimes we're showing different number of ads. Do we think showing different number of ads in this case is better or worse for the user? One of the things I try to call out is in this part, the experiment B, the dotted line represents, we are only going to log what Google is going to show the user. But the user actually only sees the experiment A. The user does not see the experiment B setting. So which means, in the logging, I wouldn't be able to have what the user really how the user really interact with the experiment B sets. So which means we have to heavily rely on this predicted user metrics. So in general, Google's ML systems are great. And, even by using the predicted metrics, that can often give us a lot of intuition what's going on with this experiment. However, this is still not ideal, which brings up a slightly more advanced experiment design, which we'll call two-arm or mirror counterfactual design. So on the left side, what we're seeing here is exactly as I mentioned. A user sees a query. The user sees the experiment A in real time, interacts with A. And in the backend, we're going to send the query through the whole flow, log what Google is going to show to this user on the experiment B. So the mirror design has a mirrored arm shown on the right. Another user sees another query. This user accidentally being allocated to experiment B. So this user is going to, in real time, see experiment B setting, interact with experiment B, right? And in the backend, we're going to take this query, passing the whole flow, serving flow, and log, should this user being treated under experiment A, which type of ads we're going to expose to the user. So the benefit of this design, although it's more complicated, is in this one, user A gets to really interact with experiment A, and the user B can also get to really see experiment B setting and interact with experiment B. So this allows us to join these two arms together and really understand how user interact with different treatments A versus B when the ads are the same, when the ads are different, when the ads ranking is the same or different, or when the ad load is the same or different. In general, I would want to say a typical A/B testing is just like a pooled t-test, while counterfactual gives me the taste of the paired t-test, right? Because on each query we'll be able to detect what happens. It certainly can reduce a lot of the noise and improve a lot of the power. But on the other hand, counterfactual, as we're seeing here, this is a very high-level conceptual illustration of what happens, but inside it requires a lot of the infra changes to make the whole logging to be accurate, to make this whole experiment infra to be useful. So it's very resource demanding, which brings up the third topic, like maybe it doesn't really matter. It's not even needed to run counterfactual for all of the queries because Google doesn't show us for majority of the queries. So which means for any experiment, if we'll be able to mark eligible slicing to pre-decide which slicing is going to likely to be treated, then we can just run counterfactual on that slicing. That saves the resource, also improves the stats power. With that, I want to talk about the third topic today, that is measure the long-term effect. So, working as department, I actually got many people ask me the questions whether my job is just trying to help Google make money. I think the answer is partly yes. Yes, my job is partly to help Google to make revenue for Google's key business, right? But on the other hand, I really need to explain to of the stakeholders as well as my external friends that our job is not just to make more money for Google. We really truly care about Google's long-term business growth. And why do I say that? In fact, as it's an interesting business, if people's mindset is always only on their money and short-term money, this is a pretty simple problem to solve, in my opinion. All I need to do is to show more ads to the users. At least the short-term wise, right? Some of the users, even by accidental chance, click on the ads, that can be the money. However, in the long term, this is not doing anyone any good. The users might find out that the ads become spammy and they might hate Google Ads. Or, even more, they might not even like Google as a platform in the future. So which is actually a long-term harm to the Google business. Because of those reasons, many years ago, almost like 10 years ago, the data science team already kicked off an important strategic effort trying to understand long-term wise users' perception to some of the treatment. So in that case, we call it user learning, and we want to really use the experiment to measure how once we expose the treatment to the user, in the long term, whether the user have learned to like the ads better, interact with ads more, or like the ads less, interact with ads less. Okay, so let me use this graph to give an idea about what we typically try to measure as a long-term effect. So if I have a treatment, right, when I talk about the long-term effect, the immediate thing coming to people's mind will be, what if like I just hold a cohort of the users under control, like do not expose them to the treatment? Then for some of the users randomly allocated to the treatment, I'll again hold these users and treating them for some time, right? The general idea is like, I'm going to observe these two cohorts of the users and find out how they interact with Google Ads, whether their behavior has been changed. Do they interact with ads more? Do they come to Google even more or less? So naively, we might even come up with a solution. How about I just look at the treated group, the user cohort E, right? Then I'm going to monitor the treated user cohort after some time at T and compare with the starting time at 0 time, right? Then I'll try to look at the difference, because then the difference here is related to, at first, the same set of the users just got started to be treated. And at time T, these users have been treated for some time, let's say 3 months. And what's the difference? However, the biggest reason this is not a great idea to measure the pure learning effect is because we're comparing the same cohort of the users at 2 different times. So there are many events can happen in between, right? For example, COVID can change of our user behavior. And also there can be some of the launches happening between and change the user behavior as well. So in general, it's not a great idea to compare the same cohort of the users, but at 2 different times. A slightly more advanced idea, sometimes we have to use it, but still not ideal, will be, what if I look at the difference, control versus experiment difference at time 0 versus the control versus experiment difference at time T. This is slightly better because this is a typical default approach. However, that approach still makes an implicit assumption that the short-term effect, if I just treat the user very quickly, the experiment versus control measured at different time is still a constant factor. So implicitly, that method still relies on, the time does not affect much of the treatment effect. So what we are trying to think about is this. Actually, let me do this. Again, the same cohort of the users treating for long term. another cohort of the users, holding them in their control production for a long time. At the measurement time, notice I made a slightly change. I changed the user setting here from I changed the user cohort here from C to T, or maybe from sorry about my notation. Okay, great. So the only change here is like at the measurement time, I flip the serving component, serving treatment for this cohort of the users. I actually have like two choices. I can say I flip the users which have been treated on a long term and flip the cohort setting to C. Then I'm going to compare. The same color just means that they're under the same cohort, the same treatment as a measurement time. Then when I compare this cohort of the users here and another cohort of the users under control, the only difference here is basically this cohort of the users have been treated for a long time in the treatment effect. This part is a little tricky, so let me try to explain again. So if we look at these users and compare to another cohort of the users, first of all, the measurement time is the same. So it's not subject to the seasonality effect, as I just mentioned. Second of all, the treatment effect at the measurement time is the same. Both of the user cohort are under the same treatment, which means the short-term treatment effect won't affect this, right? Which means the only difference left is for this cohort of the users, before I measure, they have been treated under the experiment setting for a long time. But for this cohort of the users, before I try to measure them, they have always been held in the production for a long time. That's why when I compare these two cohorts of the cookies, the only difference comes down to after being treating in the treatment for so long, what's the change in their user behavior? And that's what we call user learning. Another slightly different experimental design we come up with is again trying to expose the users in the same treatment. This is the same thing as the same cohort of the users. Constantly, we're going to expose them to the treatment. Another cohort of the users, let's say on a daily basis, we're going to cycle through, randomly draw from a cookie pool and decide whether these users are going to be exposed to the treatment experiment effect or the control effect. So this is a very interesting design because at any time, if I'm going to compare the cookie cohort, which is the first row, with any of the second row here, this tells me, the user, they're going to be measured always under the treatment effect. They're always going to be measured at the same time. The only difference comes down to how long this user had been treated. Again, the difference is just because of how long they have been treated. Therefore, what have they learned, which is the user learning effect. So this is the typical way we are going to use to measure the learning. And this is how, without sharing the details about which metric we monitor, this is actually some of the real data we just scaled. When the time goes on, we can usually observe a very nice learning curve. As time goes on, as the user being treated longer and longer, we can see the user has a very learning effect. And what is the nice is we can also sometimes see user can learn towards like us better. They're going to interact with us more often when we show them better quality ads. And sometimes if we just, for example, we just show user spammy ads, more ads, but worse quality ads specifically, we can see the user at the beginning, do not like ads a little bit, but as the time goes on, the user dislikes the ads even more, right? So this is a beautiful user learning curve we get to measure from the two experimental infrastructure that I just gave a high level overview. And in our day-to-day decision, for many of the launch experiments, right, we're going to leverage this experimental infra, trying to understand in the long term users' perception about ads. And the decision is actually based on the long-term effect rather than the short-term metrics change. with that, I think I can conclude today's talk. Overall, I would say experimentation is the key for Google to make data-driven decisions. And as the data scientist team, a lot of our job is trying to design a more meaningful experiment comparison, trying to improve Google's experimental infrastructure. Thank you very much.
Thank you so much, Kathy, for the wonderful talk. I have a question. So, how far are we from privacy preserving advertisements?
Sorry, I want to understand the question better. How far are we from privacy preserving what? Advertisers?
Advertising, yeah.
Oh, advertising. Get it. Google as a company really values the privacy. So let me use my own experience to give an example. For example, in any of the data analysis I do, I am not able to access any PII information, means the personal level privacy information. Many of the PII information either was stripped out or some ID, when I say assign a user to an experiment, etc., we're actually going to anonymize that person's information by some like a random hashed ID that nobody can understand what's going on. And if I'm going to do some analysis about some slicings, there are very strict requirements regarding how big that slicing needs to be just to protect the user privacy. Like means nobody will be able to identify, which user's data I'm looking at, right? For example, I will be able to look at the global Google Ads data. I will be able to look at the country region, like a Google data, but I won't be able to say like look at the ads Google data like for my neighborhood, even for my neighbors, right? So so Google really from the infrastructure side, from the data analysis, from the way we communicate all the information, we have always been very cautious about protecting users' privacy.
Okay, thank you so much. So, Sanjay, a question from Sanjay from our AI group. He saying, thanks, very nice slides. How much progress have you made on machine-created ads as opposed to human-created ads?
This is a great question. 2 years ago, I worked on a project exactly on that. That is called a responsive search ads. That product was in beta 2 years ago, and I heard it was launched 1 year ago, but I switched to work on something else. So as part of the company strategy, we want to apply AI, want to apply, machine learning on many things. And one of the pillar is we want to leverage machine learning to trying to help with automation. That to help the advertiser create better ads and make their like onboarding process, the ads generation process to be easier. So we're doing a lot of the work there.
Okay, another question from Jim. How does Google conduct user experiments for multi-channel ad campaigns, and how are weights assigned to changes at each touch point on each channel?
Let me try to understand the question better. I got my internet probably has a little issue. I heard like how do Google assign experiments to users? Is that question?
For multi-channel ad campaigns.
Multi-channel ads campaigns in this context, what exactly does that mean?
Jim, can you explain? Jim with us? Okay, so since maybe Jim, you can contact
Absolutely. Yeah, let me know later. I think it's probably some terminology, like we're using different terminology. I wasn't able to clearly understand this question. Sorry about that.
Okay.
Jim has another question.
Is someone talking?
Xiaosong?
Yeah, I think Jim has another question on top of that one.
Oh, okay. So yeah, so with online user testing, how do you determine the individual users in each treatment group over the long term with people using multiple devices, clearing cookies, ad blockers, and so on?
That's a very nice question. I don't have a perfect solution. because we have like very restricted privacy concerns. So, like it's not like we're going to check the user on multiple, on many devices. If you log in, like I'll say, maybe there's a way to know it's the same user. But as I said, for many of the experimental analysis, right, what we hope to achieve is an aggregated view, like treatment overall, does it do better or worse? We never really want to track any user or any like cohort of the user, like well, how many devices they use, what they do, etc.
Okay, thank you so much, Kathy, for the nice talk and the discussion and answering the questions. So with that, we reach the end of the speaker sessions.